Hey everyone, it's Amir Ali. Welcome to Code and Cadet by Sam. Today we are diving into a very important topic, load balancing in a microservices architecture. And trust me, by the end of this, you'll never look at traffic distribution the same way again. Before we jump into the topic, let's quickly see what we'll cover in this video. First, we'll talk about the key challenges you face when there's no proper load balancing, like uneven traffic, slow responses, and even system crashes under heavy load. Second, we'll break down what load balancing actually means in the microservices setup and how it keeps things smooth and reliable. And finally, we'll see how load balancing is implemented with a simple example of how requests are distributed and services stay healthy. By the end, you'll have a clear picture of why load balancing matters and how to make it work in your system. Let's start with the story. Imagine an e-commerce platform built on microservices. One of the core services, the order service, is responsible for handling purchases. A customer wants to buy a t-shirt. This order service is running on a single server under the e-commerce domain. It talks directly to a payment server, which also has just one instance. Here's what happens in a normal day. The customer places the order. The order service processes it and calls the payment server. Payment goes through. Customer gets a confirmation. Even with 50 people buying t-shirts at the same time, everything works fine. The single server can manage. At this stage, no load balancing is required. But this setup only survives while traffic is low. Now have a look at picture. The store is running a flash sale. Thousands of customers are trying to buy at the exact same moment. From the customer side, it looks the same. But inside, chaos. All requests hit that same single instance of the order service. It queues requests, tries to keep up, calls the single payment server until the order service becomes a bottleneck. The server slows down, drops requests, and eventually crashes. Customers see timeouts, failed payments, and error messages. Now, what is root cause? Root cause is the architecture was never built for high load. One instance, no load balancing, no scalability, no fault tolerance. So the developer team acts. They add another instance of the same order service. Now there's instance 1, instance 2, a load balancer even if not shown. Developer/engineering teams just trying to splitting traffic between instances. The result, performance improves, availability increases. If one fails, the other serves customers, and scaling becomes as simple as adding more instances. The platform is finally ready for big moments, sales, festivals, or viral spikes. But wait, still there is problem. A new issue appears. Traffic isn't splitting evenly. One instance gets overloaded, the other sits idle. Why? No proper load balancing or load balancer misconfiguration. Means if all traffic hit only one instance. It's like having two order counters in a restaurant, but all customers queue at one. The other counter just waits. The fix: 1. Place a proper load balancer in front. 2. Configure it to distribute traffic evenly and monitor instance health. 3. Skip failed instances automatically. Alright, before we get into the technical bits, let's first make this super simple. Think of a load balancer like a traffic police officer, or better yet, a restaurant host. In microservices, you don't have just one copy of your service. You often have multiple instances running, all doing the same job. Now if all customers hit just one instance, that poor instance will get overloaded. It will slow down, maybe even crash. That's where the load balancer steps in. When a request comes in, the load balancer decides which instance is free, which one is healthy, and where should the request go so it's handled the fastest. If one instance is busy, it sends the request to another. If one instance is down, it routes everything to the ones still working. This means no single instance is overwhelmed. The system stays fast and responsive, and your users get a smooth experience no matter how many requests are coming in. Here's a quick restaurant analogy. You walk in and the host checks both counters. Counter 1 is busy making 5 orders. Counter 2 is free. The host sends you to counter 2. Result? No chaos, no frustration. Everyone's happy. And the best part? With proper load balancing, your system can handle 10,000 or even a million requests, all without breaking a sweat. If you like this video, please give it a thumbs up and don't forget to subscribe to this channel. Your little support really helps me grow here. And hey, press that bell icon too, because I'm going to cover all Java interview question topics from basic to advanced level. Thanks for watching. Then see you in the next video. Bye bye and keep learning.